Hello, this is Python in Excel part 9. We spent some time in the previous videos cleaning up this Tour de France data set. This is the way it looks now. It's got year, rank, team, rider name, rider country, and time time is a decimal day. On this sheet, I have created some parameters that I want to use to control my chart. And for each cell, I've given the cell a name. So I've got chart width, which is, the name is here, chart height, font size for the x-axis, bar width as a percentage. That represents how much of the available space for a bar will be used by the bar. So by default, it will be 80%. This will be the chart title, an X title and a Y title, and I can leave these blank if I want. Additionally, I've put in a couple of cells from year and to year, which I'll use to control how many bars are in the chart. So this is the code that produces the chart, and you can see that there are a lot of references to the named ranges in my worksheet. The reason I gave them names rather than leaving them as cell references is that when I'm looking at the code, it's a lot easier to read and understand what's going on. So Excel is pulling data from Excel from the chart width name. Here, Excel pulling data from Excel from the 2-year name. The first line is this plot.subplots call, and because we haven't specified how many rows or columns, the assumption is that there will be one subplot within this plot. We can define the figure size in inches as a tuple. A tuple is indicated by parentheses, where the first value in the tuple is the width of the chart, so that's the chart width, which is 15 inches, and the second value in the tuple is the height of the chart, which is going to be 6 inches. So this plot.subplots produces two objects, a matplotlib figure and a matplotlib axis collection, which is actually an array of axes. So the next thing I want to do is to create the data that's going to be used. Very simply, you would put df.group by the year that you want, get the mean of the time. That's pretty simple, I think. And then at the end, you can put .plot and tell it what kind of chart you want to use. Assign to the ax attribute of the plot method the ax object that was produced by the plot.subplots, and then we can decide how wide we want each of the bars with this width property. Now this part about the mask is a way of filtering a data frame, and I've defined the filter on the line above. So I'm saying if df.year is greater than or equal to the from year and df.year is less than or equal to the 2-year, the mask series will be true if it meets those conditions and false otherwise. And if I pass a true-false series into the index of a data frame, it effectively filters the data frame. You should be familiar with that if you've used the filter function in Excel. This part may look a bit odd. When we say the word spine in Python, we're talking about the lines that appear around a plot area. So for spine in ax.spines.values, we're iterating through each of the spines. So this is essentially the border of the chart. And for each spine, we're making it invisible. So that will produce a nicer looking chart, because who wants a box around your chart? Next, we can apply some formatting to the X ticks, which essentially means the axis labels. We're going to rotate them. And this horizontal alignment means how are they aligned relative to the bar that they belong to. So we say center so that the text will appear immediately below the bar in the middle. And the font size is pointing to this X font size cell. Tight layout just tries to remove any extra space that might have been created around the object in the chart. So extra space around the axes between the chart and the title and so on. And then plot.show just produces the plot. And if I select that cell, you can see that it's actually a rich data type, and I can select the image and display it in the next cell. But of course that's way too small. So let's right click on that and choose picture in cell, create reference. Looking at this chart at first glance, I can see that, oh, there were no timing information for the years between 1904 and 1913. So let's change the from year to 1913. One thing I do notice about this chart is that from the 1913 to about 19, let's say 28, the mean time was much higher. And it turns out that the distance of the Tour de France during those years was frequently over 5,000 kilometers, whereas it dipped down to be over around about 4,000 kilometers for this period. And then after about 1988, the mean distance was approximately 3,200 kilometers. Let's change the 2 year, 1928. So that's a way that you can control what's displayed on your chart using named cells. You can see that I've collapsed the chart configuration because these are things that are really, once you've got them right, you don't want to change them again. Let's collapse that. And that's it. Very basic analysis using matplotlib and using Excel named cells to control what is shown on your chart. Thank you for watching. I hope you enjoyed it. Have a great day.